This is everyday mathematics once again, and today we're shifting from the qualifying test at the MIT 2023 Integration B into the regular season polynomials. We'll look at the second question, which was x plus 1 over x plus 2, all that over x plus 3 over x plus 4, integrating from 0 to 1. The next question was question number 3, which was the integral of minimum between 2x and 5 minus x over 2 minus a maximum between negative x over 2 and 2x minus 5, integrating from 0 to 3. The next question was question number 4, which was 1 minus 1 over 1 minus 1 over 1 minus 1 over until 2023 1 minuses, but the last component there was 1 minus 1 over x. Question number 6 was next, which was x to the power 6 plus x to the power 4 minus x squared minus 1 over x to the power 4 times e to the power x plus 1 over x. Question number 7 was next, which was the integral of 1 over the square root of the product of x plus 1 cube and x minus 1. Question number 9 was next, which was the inverse of the integral of the inverse of the binomial coefficient of x and 5. Question number 15 followed, which was the integral of 1 over x minus 1 squared plus 3 over x minus 3 to the power 4 plus 5 over x minus 5 to the power 6, all that over 1 plus, in bracket, 1 over x minus 1 plus 1 over x minus 3 cube plus 1 over x minus 5 to the power 5, all that to the power 2, integrating from negative infinity to positive infinity. And then question number 18 was next, which is x plus 1 over x plus 2, that times x plus 3 over x plus 4 times x plus 5 over x plus 6, continuing all the way to infinity, and that integrating from 0 to infinity. So these are very interesting questions. I hope you will enjoy our solutions to these problems. Now, before we proceed, I would like to encourage all of you to subscribe, because when you subscribe, we, one, get traffic directed our way, two, you get notifications each time we come up with solutions that may be interesting to you. So highly encourage you guys to subscribe. Thank you. So on to question number 1. So on to question number 1, which was the integral of x plus 1 over x plus 2, or all that over x plus 3 over x plus 4, integrating from 0 to 1. So the first way I would kind of attack this question is just using regular division. And so when you're dividing fractions, you obtain the reciprocal of the divisor and multiply to the item in which you're dividing. And so here, x plus 1 over x plus 2 times x plus 4 over x plus 3 from 0 to 1 would be our integral. And so the next thing is express x plus 1 in form of x plus 2, which is x plus 2 minus 1 over x plus 2. And then x plus 4 also could be expressed in terms of x plus 3 in the denominator, which is x plus 3 plus 1. And that now becomes the integral of 1 minus 1 over x plus 2 plus 1 over 1x over x plus 3. Now multiplying through gives you first of all 1 across, so 1 times 1 is 1, 1 times 1 over x plus 3 is 1 over x plus 3, then negative 1 over x plus 2 times 1 is negative 1 over x plus 2, and then negative 1 over x plus 2 times 1 over x plus 3 is negative 1 over x plus 2 times 1 over x plus 3. Now, the next thing now is to express the final product there, this product into partial fraction, which is the same as you can see here, brackets of 1 over x plus 2 minus 1 over x plus 3. So that when you combine, it becomes x plus 3 minus x plus 2, and you remain 1 at the top. So then we distribute and collect like terms. So you have 1 plus x plus 1 over x plus 3 plus 1 over x plus 3. So you have 2 over x plus 3 minus 2 over x plus 2. And this is the same as 1 x when you integrate plus 2 natural logarithm of x plus 3 minus 2 logarithm x plus 2, natural logarithm of x plus 2 from 0 to 1. So you can play around with that so that you get x plus 2 log of x plus natural logarithm of x plus 3 over x plus 2. Substituting our limits in there yields 1 plus 2 log of initially 4, that's 1 plus 3 over 1 plus 2, which is 4 over 3, minus 2 log of 0 plus 3, which is 3, 0 plus 2, which is 2. Now using the law of logarithms, we can multiply or divide the like terms. So before we multiply by getting the reciprocal of what is within the log function, the negative sign here turns into positive, and then you can go ahead and just multiply the fraction. So we have 4 times 2, which is 8, 3 times 3, which is 9, and then now we can take the 2 up so that we square the fraction, and therefore you get 1 plus natural logarithm of 64 over 81. And then you could also express it as the reciprocal of this fraction, and so it becomes 1 minus natural logarithm of 81 over 64. And this is your final answer. Okay. So the next problem, as we said, was the integral of the minimum between 2x and 5 minus x over 2 minus the maximum between negative x over 2 and 2x minus 5. So personally, I would just draw the graph. These are all linear functions, so the lines should be pretty much straight. And so looking at the first item here, plotting the graph of 2x and then of 5 minus x over 2. And as you can see, from 0 to 1, 2x is less than 5x, 5 minus x over 2, and then beyond 1, 5 minus x over 2 is less than 2x. And then, so the second item here, we can plot the graph of 2x minus 5 in the yellowish line here, and then the blue is negative x over 2. And as we can see, initially, since we are focused on what is greater or what is the maximum, we see from 0 to 2, negative x over 2 is greater, and then beyond 2 to, and that's 2 to 3, 2x minus 5 is greater than negative x over 2. So we can say, just to summarize what I've mentioned, from 0 to 1, 2x is minimum. from 1 to 3, 5 minus x over 2 is minimum. And then for the second item there, from 0 to 2, negative x over 2 is greater than 2x plus 2x minus 5, so negative x over 2 is our maximum. And then from 2 to 3, we see that 2x minus 5 is maximum. So we'll choose negative x over 2 in this interval and then 2x minus 5 in the second interval. However, there are obviously more than two combinations. So we'll have three intervals. We'll have 0 to 1. Look at the combination of minimum and maximum on both sides. And then we'll have 1 to 2, and then from 2 to 3. And so essentially your integral now becomes the integral of first of all from 0 to 1 of 2x, which is minimum, minus x over 2, which is maximum in that interval. And then from 1 to 2, we shift now the new minimum. The first component here is 5 minus x over 2 minus x over 2, since negative x over 2 is still the maximum in that domain. And in the last domain, from 2 to 3, 2 to 3, we have 5 minus x over 2 minus 2x minus 5. And so we now have a beautiful 2x plus x over 2 plus 5 minus x over 2 plus x over 2, and then here interval 2 to 3, we have 5 minus x minus 2x. The two negatives here results into a plus 5. So eventually we have a 5x over 2 in the first interval. We have here this and that cancels, and so you have 5 over 2 left. And then from 2 to 3 here we have 15 minus 5x over 2. And so when you integrate now, you have 5x over 4 squared from 0 to 1, then 5 over 2 x 1 to 2, and then 15 over 2 x minus 5 over 4x squared from 2 to 3. So we have 5 over 4 here, because 1 squared minus 0 squared is 1, and then here 2 minus 1 is 1, so we have 5 over 2 left here. And then for the first item here we have 15 over 2, because 3 minus 2 is 1, and then 3 squared minus 2 squared is 5. 3 squared, yeah, it's 5, so 5 times 5 is 25 over 4. Then now getting a common denominator here, we use 4, so 4 times divided by 4 times 5 is 5, 4 divided by 2, 2 times 5 is 10, 4 divided by 2, 2 times 15 is 30, minus 4 divided by 4 times 25 is 25. And so eventually we get 20 over 4, and the answer is 5. So this is the final answer. Okay. The next problem is quite interesting, and that is these nested fractions. And so one way of looking at it is you first of all look at the first 1 minus. As you can see, it is 1 minus 1 over x, and so it's the same as x minus 1 over x. Then you look at the second 1 minus, not negative 1, that results into 1 minus 1 over this value x minus 1, which results into negative 1 over x minus 1. And then the third one minus what results, that is 1 minus 1 over this value here. And then as you express it, this becomes x again. So we are back to this initial loop. So every three fractions up, we get back to the x. And so and the cycle just continues as I've mentioned. Now, since we have 2023 here, so up to this point, we have 2022. And since 2022 is divisible by 3, as we've seen here, the cycle repeats every 3 computation upwards. So at this point here, in place of this rectangle here, this would be the same as x. So the integral of all that complicated looking integral is the same as 1 minus 1 over x, which is just x minus log x. So as simple as that. And this is the final answer. Next problem is the integral of x plus 6 plus x to the power 4 minus x squared minus 1 over x to the power 4 times x e to the power x plus 1 over x. So the first thing I would do is actually do the actual division by x to the power 4, and this results into x squared plus 1 minus 1 over x squared minus 1 over x to the power 4 times e to the power x plus 1 over x. And so the next thing I could do here is, since I see this value here and this value here seem to look like the derivative of this, so I could isolate this term here out, and what we have next is now x squared minus 1 over x to the power 4 times e to the power x plus 1 over x, and then 1 minus 1 over x squared. So this is the same as the derivative of e to the power x plus 1 over x. Okay, now so we could just abbreviate that pretty nicely. Sorry, this is e here. We can abbreviate that into this is e, the integral of x squared minus 1 over x to the power 4 times e to the power x plus 1 over x times the derivative of e to the power x plus 1 over x, because this entire term is the derivative of this. So the next thing we'll do is we'll expand out. We'll try to investigate and express this term here in form of the product of this derivative of x plus 1 over x. And there I do long division. So I have x squared minus 1 over x to the power 4. I divide it by 1 minus 1 over x squared times x squared. You get x squared minus 1 over 4. And then you subtract that, you get 1 minus 1 over x to the power 4 times 1. You get 1 minus 1 over x squared, and so now eventually the difference now is 1 over x squared minus 1x x to the power 4, and you multiply by 1 over x to the power 4 to the divisor, and you get something like similar to this. And so when you subtract, you get 0. So essentially what happens here is that x squared plus 1 over x squared times 1 minus x squared times e plus 1x dx is the first part of the integral, plus the integral of the derivative of e to the power x plus 1x. Now, the other thing we could do now is we can now abbreviate this as we've written here. Next thing we could do is use the product rule. So as you can see here, this is the derivative of this, and so the antiderivative is e to the power x plus 1 over x times this initial value, and then inside the integral sign, now we derive this value that was not differentiated, and so we get 2x minus 2 over x cubed times then now e to the power x plus 1 over x. Again, product rule, integral by parts, integrating by parts. And so what this now results into is something much more nifty, because this 2x minus 2 over x to the power cube is the same as 2 x plus 1 over x times 1 minus 1 over x squared. Again, this is the derivative of e as we've expressed here, and this power is the same as the power here. So you can use again integration by parts. It means a little bit nested, but we can continue doing the same thing as shown by the big brackets here. So the antiderivative e at the power x plus 1x times the x plus 1 over x. Now inside the bracket, when we obtain the derivative of x plus 1 minus x plus 1 over x, and so these two values here now is the same as the derivative of e to the power x plus 1. So the integral now becomes this initial value minus 2, the big brackets, x plus 1 over x e to the power x plus 1x minus the derivative of e to the power x plus 1 over x. So this is the same as x squared plus 1 over x squared times e to the power x plus 1x minus 2 in bracket x plus 1 over x e to the power x plus 1 over x minus the derivative of x plus 1 over x plus the integral of the derivative of x plus 1 over x. So very quickly that becomes x squared plus 1 over x squared times e the power x plus 1x minus 2 x plus 1 over x times e to the power x plus 1 over x plus, now negative times negative here, plus the integral of this part here now becomes 2 e to the power x plus 1 over x, and then again here we have the same which is the third, the fourth, e to the power x plus 1 over x. Now combining like terms, what results here is x squared minus this 2x plus 1 plus 2 plus 1 is 4 minus the negative 1 over x, so this is 2 over x, and then the x squared term here remains the same constant, times this value that is common to all these terms, e to the power x plus 1 over x, and then adding constant. So this is the final answer. It was a little bit convoluted, but that's the final answer. Next problem quickly is problem number 7, which is derivative or the integral of 1 over the square root of the product of x plus 1 cube and x minus 1. So what I would do is I would let u be equal to the square root of x minus 1, and so du is the same as a half of dx over square root of x minus 1. And so what that means is u squared is the same as x minus 1, and therefore u squared plus 1 is the same as x. And so into this derivative integral, we can now substitute in where we have x plus 1 is the same as u squared plus 2, because x is the same as u squared plus 1. And then since dx over square root of x minus 1 is the same as du, and then there's this constant, so this part here becomes same as twice du, and that's what we've put here. And so we can use a substitution of let u equals to square root of 2 tan theta, which is the same as du is equals to the square root of sec square theta d theta. Substituting everything in there, we get 2 times 2 square root of 2 sec square theta d theta, and in the square root sign we get 2 tan square theta plus 2 cube, and so when you do further manipulation you get 2 integral d theta over 2 sec theta, and this is the same as cos theta, and obviously these two cancel out. And so that integral, same as cos theta, when you do that, the answer is sine theta. Now we know theta was, we know that the u was set to square root of 2 tan theta, so theta is the same as 2 over root 2 arctangent, and then we can also replace u with x, which is x minus 1, so it's the sine arctangent of root of x minus 1 over root 2, and then further manipulation means that sine theta can be expressed as the square root of 1 minus cos square theta, cos squared, and in there we can now express cos squared as sec squared, and that's obviously reciprocal of cos squared, and then expressing sec squared as identity of tan squared, so this same as 1 plus tan squared, and so this entire value now pops out nicely. So the same as now, the answer is same as square root of 1 minus 1 over 1 plus x minus 1 over 2. Then simplifying the fraction is the same as 1 minus 2 over x plus 1. Common denominator, this is the same as the square root of x minus 1 over x plus 1, and this is the final answer. Next step is problem 9, and this is the binomial coefficient, the inverse of that. So binomial coefficient, we know that as the top value as the factorial of the top value over factorial of the bottom value, and then the factorial of divided again by the factorial of the difference of the two values. And for the 2, now we have x factorial over 5 factorial, x minus 5 factorial. Now we know x factorial to be the product of x all the way to 1, and then 5 factorial, that is just a constant, and then x minus 5 factorial is x minus 5 product all the way to 1, so these would cancel with the x minus 5 all the way to 1 in the numerator, and so we get that as x times x minus 1 times x minus 2 times x minus 3 times x minus 4 over 5 factorial. So the inverse now becomes 5 factorial over x times x minus 1 times x minus 2 times x minus 3 times x minus 4. To solve this, what I would do is I would try to convert this into a partial fraction, and how I would do that is express it as a over x, b over x minus 1, c over x minus 2, d over x minus 3, e over x minus 4. The first thing I'll do is multiply x through, so that there is x times x here, and then times x across this side, and then set x to 0, so that where the x's don't cancel here, every term becomes 0, and we are only left with the a. And then since we are substituting 0 into the x, you have the product of 1, negative 1 times negative 2 times negative 3 times negative 4, and then all that divided by in the numerator we have 5 factorial. So a is the same as 5 factorial over 1 times 2 times 3 times 4, which is the same as 5. And then to extract b, again you multiply both sides with x minus 1, and then set x to 1, and so the values that don't have x minus 1 term cancel out. Those terms they do tend to 0, and so b now becomes 5 over this is 1, and since the x minus 1 term gets cancelled when you multiply by x minus 1, now we have 1 minus 2 is negative 1, so negative 1 times negative 2 times negative 3, so b becomes negative 20. And then multiplying by x minus 2, the same process happens, and c becomes 30, multiplying by x minus 3 and then setting x equals to 3, and so that allows us to obtain d, which is negative 20. And then lastly, finding for e, apologies again, e, we find it to be 5. So our fraction or partial fraction becomes now 5 over x, negative 20 over x minus 1 plus 30 over x minus 2 minus 20 over x minus 3 plus 5 over x minus 4. And so when we integrate that inverse of the binomial coefficient of x and 5, we get 5 natural logarithm of x minus 20 natural logarithm of x minus 1 plus 30 natural logarithm of x minus 2 minus 20 natural logarithm of x minus 3 plus 5 natural logarithm of x minus 4. So I had forgotten to include natural logarithm of x minus 2 here. Okay, and so this is your answer. Then our next problem is number 15. This was very interesting. I think most people would get tripped by this problem, which is the integral of 1 over x minus 1 squared plus 3 over x minus 3 to the power 4 plus 5 over x minus 5 to the power 6 plus over 1 plus bracket 1 over x minus 1 plus 1 over x minus 3 to the power 3 plus 1 over x minus 5 to the power 5. As you realize that this is a negative of the derivative of this, so there is some form of relationship here. So how I would begin is by setting let u be equal to this component here, and then when I derive du with respect to x, I get whatever is in the numerator but the negative sign. And so what now happens is that this integral without the limits initially is the same as the integral of negative 1 over 1 plus u squared. So this is a famous integral, 1 over 1 plus something squared is the same as, when you integrate that, is the same as arctangent of that fraction, the variable. So negative 1 over 1 plus u squared, when you integrate that, is the same as negative arctangent of u. And then so when we plug in our limits there, that means that that's the same as the negative arctangent of 1 over x minus 1 plus x minus 3 cubed plus 1 over x minus 5 to the power 5. Limits negative infinity, positive infinity. Now this is a very tricky problem. Most people would be tempted to plug in these limits straight away, but that would be a fatal mistake. As you can see here, there are points of discontinuities or singularities, like x minus 5. When you put 5 here, x is equals to 5, this entire fraction goes to infinity. So it's very crucial that you factor that in your calculation. So what I would do is I would take, first of all, the limit from from the positive side of 5, because it's important how are you approaching that singularity, from the negative direction and the positive direction. So we begin from the positive direction all the way to positive infinity, and then we move from the positive side of 3 to the negative side of not negative in the literal sense, but the side through which you're approaching that asymptote. So from positive 3 all the way to the negative side of the asymptote of 5. And then from the positive side of x is equals to 1 to the negative side of x is equals to 3, and then from negative infinity to the negative side of 1, x is equals to 1. And as you can see, since it tends to infinity around this point here, this value tends to 0 at infinity. So we have initially pi over 2 minus 0, because there's a negative side, so the lower limit becomes the positive. And then here we have, at these 2 points, we have pi over 2, and then there's negative pi over 2. So we have pi over 2 minus pi over 2. The same thing happens to this, and lastly we have pi over 2 minus 0. So what this essentially means is that we have pi over 2 plus pi over 2 plus pi over 2, pi over 2 plus pi over 2, pi over 2 minus 0. So the final answer is 3 pi. But that's very crucial for you to investigate these intermediary singularities for you to get an accurate answer. Otherwise, if you plugged in infinity and negative infinity, you would get a 0, and that would be a mistake. So 3 pi is our answer. And lastly, problem 18, which is the integral of x plus 1 over x plus 2, x plus 3 over x plus 4, x plus 5 over x plus 6, all the way multiplied to infinity. So how I would approach this problem is I would express the numerators in form of the denominator. So for example, the first value there is x plus 2 minus 1 over x plus 2, x plus 4 minus 1 over x plus 4, x plus 6 minus 1 over x plus 6. And so this results into 1 minus 1 over x plus 2, 1 plus 1 over x plus 4, and so on to infinity. Now as you realize that each term here is less than 1, especially for x value that spans above 0 to infinity, so for positive values of x. Now what that means is that when you're multiplying a fraction which is less than 1 many times to infinity, this value really just tends to 0. Um, in the need of, you know, the mathematical way of expressing this is using this symbol here, but I know what is under this integral sign is 0. So that integral is the same as the integral of 0. Integrating 0, you get a constant, and if you have the limits, so the answer is essentially 0. Um, so that really brings us to the end of the polynomial questions in the regular season questions. I hope you enjoyed our solutions. If there's any question, please leave a comment in the comment section. I really encourage you again to subscribe to our channel. We enjoy doing this, and so that subscription gives us more visibility, but also allows us to, it motivates us to keep working at this. Thank you very much, and yeah, we'll see you in the next video.